Right, the animals have been fed and are all well behaved, aren't you, Fendi? So, okay, a pattern is made by 4 identical squares. The sides of the squares are parallel to the axes. The coordinates are 6, 7, 38, 36, and there's a C value there, and it wants to work out the coordinates there. So I immediately can see that there's a distance right across here and a distance right across there. And because these are identical, if I work out that distance, it goes from 6 to 38. That's a total distance of 32, and there are 4 of them, so they must go in groups of 8. So therefore, the x-coordinate there must be 6 plus 2 lots of 8, which 2 lots of 8, 2, 16, 22. Now my y-coordinate is I've got from 36 down 8, down 8. So for the y-coordinate, it's a similar idea, 36 minus 2 lots of 8. And that's 36 minus 16, so that's 20. So therefore, that's my coordinate points, 22, 20. Oh, write it out properly. There you go. Now, obviously with this, it's worth 5 marks. It's quite complicated, but if you take your time, it's question 6, you can do this. You should do okay on it. Just have to breathe and spend the full 5 minutes on it. Don't rush it. Question 7. Okay. It says here that shape T is reflected in the line x equals minus 1. Now remember, x equals minus 1. If you think about this, that means every x value, whatever the y value is, every x value is minus 1. So minus 1, 0, minus 1, 1, minus 1, 2. So eventually, if you did it that way, you'd say, this is your mirror line all the way down here. And shape T is reflected in this. So it's the same distance from the mirror line. So that's 2, 2 there. That's distance of 4, 4 there. Distance of 3, 3 there. And there we go. And it says this is R. And then it says R is reflected in the y equals minus 2 line. So here, all our y values, all these, are minus 2. So that must be this line here. By sort of deduction from the previous one, you see that. And it says it's reflected here. So that's 3 down. So there, must be there. And that's S. And then it says, describe a single transformation that will map T to S. And with this one, you can see it is going to be a rotation. So it's got to be a rotation. Now with this one, you've got to say a number of things. 2 marks, you've got to say the order of rotation. So like, you've got to say it's, in this case, 180 degrees rotated. Doesn't matter if it's clockwise or anti-clockwise, but then you've got to work out where the center of rotation is. Now you could have a tracing paper, this isn't good, so that's no good with tracing paper. So what I can do instead is I can then connect these points here. So I'm going to connect that point, and if I think about where it is, that goes to there, doesn't it? That point is there. So if I drew a straight line there, and then I drew a straight line there, and I drew a straight line there, you see it all goes there, and miraculously that's exactly where the 2 mirror lines meet. So that seems more than just coincidental, doesn't it? So there you go. So you'd say it rotates, and you don't say anti-clockwise or clockwise because it's 180 degrees, but you have to say 180 degrees about, because that says the center point, and then I need to put the center point here, minus 1, minus 2. And that's really nice, and that's feels really confident, doesn't it? So let's see if we can squeeze in question 8 in this set of recordings. Here goes. The perimeter of a right-angled triangle. Right, so I'm going to draw a right-angled triangle out, just so that I remember what it looks like. And the perimeter equals 72. And then it says the lengths of the sides are in the ratio of 3 to 4 to 5. Now that 3 to 4 to 5, it's a Pythagorean triple. If you remember anything about Pythagorean triples, it's a Pythagorean triple, and they're quite often well used in building trays, etc. Work out the area of the triangle. So 3, 4, 5 must mean that is 5, the hypotenuse. That's 3, and that's 4. It doesn't matter if this, I know it's not drawn to scale. I mean, that could be 4, that could be 3. Let's do that anyway. It doesn't really matter. Honestly, it doesn't. But we know that this perimeter is 4 times the value, which is 5 times the value, which is 3 times the value. Let's call that value x. So I can do that. So I know that if I add all these together, the 3x plus the 4x plus the 5x, that should give us a perimeter of 72. Which means if I did that, I've got 12x equals 72, and that means that x is 6. So all these are 4 lots of 6, 3 lots of 6, 5 lots of 6. And it wants the area of the triangle, which is a half base, which is 3x, okay, times height, which is 4x. And the thing is, I know the value of x is 6. So it's going to be a half times, now 3 6s are 18, times 4 6s are 24. Now the thing is, this is with a non-calculator, so this is where it gets a bit more fun. So let's help you out here. What I can do is I can halve the 24, because that's the biggest guy. So I know it's going to be 18 times 12. And so let's just do this. 2 8s are 16, 2 1s 2 plus 1 is 3. And then I'm going to times by 10. So I'm going to always end with a 0. Now 1, 1 8s, 1 1s. And there we go. So that's 6. That's 1, remainder 1. So that's 216 centimeters squared. And if you're doing this and you want to check it at home, always open up the mark schemes if you want to and check, because there they are and they show you all what to do. Maybe a different way to what I've done, but that's really good.